Hello and welcome to another GCSE revision video, and in this video we're going to be looking at pie charts. Pie charts are a great way of showing the relative proportions of the frequency. The relative proportions are much easier to see, but the actual frequencies are harder to read as some calculation is involved. If you want to make it easy for your audience to see the actual frequencies, you're better off using a bar chart. But if you want to make it easy to see the relative frequencies as a proportion of the whole, then you're better off using a pie chart. Let's go back to my hypothetical garden and these hypothetical birds that came and visited. We drew up a tally chart, we drew up a frequency chart, and then we decided just for fun we'd add another table where the frequency was converted to a percentage. So what I've done with my chart, I've taken the frequency and I've divided it by the total, and I've multiplied that by 360 degrees to get 3 over 20 times 360 degrees equals 54 degrees. What I could have done instead is take my frequency as a percentage, or 15%, and divided that by the 100, so I've got 0.15 and multiplied that by the 360 degrees. So to generalise, we take the frequency as a number, divide it by the total and multiply it by 360 degrees. It's almost identical to the way we would calculate a percentage, only instead of multiplying by 100 we're multiplying by 360. Okay, so what I've done is copy pasted my frequency table along with my angles into Microsoft Paint so that we can draw our pie chart. So to draw our pie chart, the first thing we do, once we've calculated our angles, is to draw a cumulative angle. So we need another column, so I'm going to write 54 degrees here. And now the next one along will be 54 degrees plus 54 degrees, so that's 108 degrees. And now the next column, or the next row down, is 108 degrees plus 108 degrees, which is going to be 216 degrees. And now the next number down will be 216 degrees plus 36 degrees, so that's 252 degrees. I could put the degrees in, but it's okay. So the next one, we're going to add 72 degrees to 252 degrees, so that is, what is that, 324 degrees off the top of my head. 2 plus 2 is 4, so this unit's going to end in a 4. 7 plus 5 is 12, so this is going to be a 2, and we carry the 1, so that's 324 degrees. So the next one is 18 degrees, so we have to add 18 degrees to 324 degrees, so this is going to end in a 2 because 4 plus 8 is 12, carry the 1, 1 plus 2 is 3, 3 plus 1 is 4, so that's 342 degrees. And then we need to add 18 degrees to 342 degrees. Well, 8 plus 2 is 0, which is reassuring because I'm hoping this will come to 360 degrees. So then we carry the 1, so that becomes a 5, and add the 1, that becomes a 6. So yes, it does indeed come to 360 degrees. Okay, so those are the angles we're going to need to draw. Now on a pen and paper you wouldn't have these fancy lines which I've painstakingly drawn in. Only kidding, I wrote a Java program to do it. But you would use a protractor, you'd use a compass to draw your circle, and then you would use a protractor to measure your angles that are relevant, and the relevant angles are these angles that we've just calculated here: 54 degrees, 180 degrees, 216, 252, 324, 342 and 360. But of course those would change depending on the angles you've got in your angle column, which would depend on your raw data, because you won't be doing the same chart that I'm drawing. So the angles represent the cumulative angle of the angle column in your frequency chart. Now you don't have to have your 0 degrees pointing straight up. You can choose where you're going to put your 0 degrees, but wherever you put your 0 degrees you need to then count your angles. They can go clockwise or counterclockwise, but so long as you're consistent, that's okay. So I'm going to draw a line to my 0 degrees. Conventionally the 0 degrees go straight up as if these are bearings, but there's no law that says they have to. You're not going to go to prison if you don't. So that's my 0 degrees. So now my first angle that I need to put in is 54 degrees. So I'm going to try and draw a line. You would use a protractor. You would line up your protractor with your 0 degrees, and then you would measure off the 54 degrees, and then you would put a little dot or something at the 54 degrees, and then you draw a straight line through your dot to the circumference of your circle. So if that is 50 degrees and this is 55 degrees, then 1 degree less would be 54 degrees. Okay, and what I can do now is I can fill this in whatever arbitrary colour I want. I'm going to choose this. Oh, I didn't want to edit the colours, I just wanted to pick a colour. Okay, I'll choose that colour. It doesn't matter what colour you pick. So I'm going to now copy this colour here, and I'm going to draw a little square of that colour, and that's going to make up my key. And the first of my birds is a finch, or the column that has that angle is a finch, so I'm going to draw a finch. And that's the start of my key. So then I'm going to do the same thing for the 108 degrees. So this is another 54 degrees, but of course we're starting from 54 degrees, so that's why I added the 54 to the 54 to get 108 degrees. So I now want to measure to 108 degrees. Alternatively, if you didn't want to draw these numbers in, what you could have simply done is use your protractor and make the 54 degrees your new 0 line to measure another 54 degrees. I chose to actually calculate it as cumulative angle. So where do I want to go? 108 degrees. Well, 110 degrees is here. 109, 108 I think would be about here. Now to be honest, when you blow up this pie chart, it's very difficult to actually read off the angle anyway. You'd have to carefully measure it, and I don't think anyone's going to shoot you if you get the wrong angle. If it's out by about a degree here or there, I don't think anyone's actually going to notice, let alone care. So let's have orange. Or to my colourblind eyes that looks like orange. Don't scream at me if it's not orange. I'm going to use that same colour to draw a little square. And that's a pigeon. And this is how I'm going to go all the way through my pie chart. So the next one is 216 degrees, so I'm going to take a line and I'm going to measure down to 216 degrees. So that's 210, that's 215, and one more, I make it 216 degrees here. And I'm going to pick this colour, which I think might be red. Does that look very similar to the same colour? It does. It's too similar to the same colour. I'm going to pick a green. The colours should contrast nicely so that you can clearly see which colour's which. And so what we have here is a seagull. Oops. Okay, so that took us down to 216 degrees. So the next one is at 252 degrees. So I'm going to draw my line to 252 degrees. Well, that's 250, 251, 252. I make 252 degrees about there. And I want to copy, and the next one is a robin, so I'm going to pick this colour, I think. I'm going to fill that. Copy that. And paste. Of course, you draw little squares with your pen, with your coloured pens. Unless you had space in your chart to actually draw the categories into your actual pie chart, which is perfectly acceptable. And what did I say? Did I say that was a robin? I guess that was a robin. I can change it if it wasn't. Yes, after seagull came robin. Okay, so now our magpie, that was 250 degrees, so this is 324 degrees. So again, I'm going to draw from the centre out to 320, so this is 325, so this next one just before it will be 324 degrees. And I'm going to pick, haven't had that colour yet, so that looks pink to me. I'm going to draw it down here. That's very weird. There we go, magpie. Right, so what's after magpie? Crow. So that's now 342 degrees. 340, 341, 342 degrees. And I'll colour that one in. I'm going to pick a nice yellow. So that's a crow. I should have chosen black for a crow, shouldn't I? Because crows are black. But never mind. Mind you, so are magpies. So this is crow. And that leaves sparrow, which takes us up to 360 degrees. I'm just going to pick a random colour for that. Actually, let's have this colour, whatever it is. That's the curse of being colourblind. You really don't know your colours. A lot of them look very similar. Okay. That's why I'm choosing as high a contrast between colours as I can, because it helps colourblind people like me to actually see the difference. If you choose nice subtle shades, it's going to be very difficult for people to actually see the difference. And so that's a sparrow. Okay, so let's zoom out and see this whole thing. Okay, so there's our pie chart, very nicely coloured with all the angles representing the relative frequencies. Okay, so our finished pie chart has had all those graduations removed, which wouldn't be there in your pie chart because you'd be using a protractor anyway. Title's been added, and we've recoloured it and changed the way we've laid out the key. But other than that, that's just how to do a pie chart. One little word of caution: in these angles, they all add up very nicely to 360 degrees, just like the percentages add up very nicely to 100%. Chances are on your GCSEs they will add up that nicely, because the examiners are just trying to test if you know how to do a pie chart. In the real world, due to rounding errors, you'll have like decimals of a percent or decimals of an angle. So you might have something like 53.8 degrees or 52.1 degrees or whatever, and when you've rounded them up to the nearest degree, because your protractor only shows single degrees, you might find that due to all those rounding errors you end up with 359 degrees or 361 degrees. Use your best judgment as to where to shave off an angle here or add an angle there to normalise it to 360 degrees. Again, nobody's going to quibble over plus or minus a single degree on a pie chart. Of course, if your angles are way off, people are going to notice. Your angles must look vaguely like the relative proportions. So in this case of a very, very badly drawn pie chart, if your angles don't look anything like the relative proportions, then your pie chart is just plain wrong, and it will completely misrepresent the data. So strive to make your angles as accurately as you can, but don't cry if you're out by just plus or minus 1 degree, because nobody else is going to. Okay, I hope that was helpful. I'd like to wish you all the best with your revision and all the best with your exams, and I'll see you in another video.